This is the third event of the Greener Together, a practical guide to local urban construction. These events are part of a wider project where the University of Hertfordshire partnered with St Albans District and City Council, and we apply for a fund by Innovate UK. Part of this fund was to improve sustainability all across the St Albans district. And of course, because these lectures are open online, we hope to make even a wider impact on the sector. And in the past events, we have even people attending from abroad. The project is aimed to empower local people and groups to make a difference through innovative behavior change campaign. We would like to enhance the understanding of people from every sector, from every background, to understand how everyday choices have an impact on the life of all of us. And all these effort will help us to make small changes and reduce energy and transportation emission. I leave now the stage to Deepti, which alongside me coordinate this series of events. Please, Deepti.
Hi, everyone. Thanks, Luigi. I'll introduce Christian and then hand it over to him to continue the presentation. So Christian, as you all might already know, he has an immense amount of experience coming from 2 decades at Archetype, and he's designed some of the most complex projects with natural materials. And he's even delivered UK's first net zero school, and I think some of the slides will speak about it. And we're very happy to have you here, Christian, and I'll start presenting, and over to you now.
Brilliant. Thank you very much for having me. It's a real honour to be here, and yeah, do ask questions in the chat as we go along, and I'll either answer them during the session or afterwards. So are we...
Do you see my screen?
Yes, now it's coming through. Just 1 second. Brilliant. So if we can move on to the next slide, that would be brilliant. So I've already had a bit of an introduction, but it's worth just probably touching a little bit more on a couple of projects. So as we say, I'm from Archetype Architects, and we've been delivering some of the leading sustainable projects, meeting world-leading energy performance targets such as Passive House, whilst using natural materials throughout. In a moment, I'll show you 3 example projects of projects that I've delivered personally. These include the Enterprise Centre at the University of East Anglia, which was listed in the top 17 buildings in the world at the recent COP conference, COP18. And that's made from, it's got natural, there you go, straw in the top right-hand picture. It's got straw cladding, which is a beautiful project, and I'll talk a bit more about that later on. In the middle is Harris Academy, Sutton, a large secondary school, and you can see there that's the sports hall, and it's full of cross-laminated timber. It's all beautiful timber buildings throughout. And in the bottom corner is Hackbridge Primary School, the first net zero carbon building standard, Passive House Plus building, and that's all made from natural timber as well. So yes, moving on to the bulk of the topic, what materials would we choose, and why do we choose materials? So it's really important as we begin this topic to think about why you pick and choose certain buildings on site. Here are a selection of some of the material palettes we've used, and the rationale for them, as you can see, is in the middle there. The products you can see from top are recycled plastics. I think that top one is the Smile plastics, reusing toothbrushes, although it could be the wellies, both of which have been discontinued, but there's very similar products since then. In the top right-hand corner, you've got water-based, non-toxic paints. Thinking about natural materials, you also need to think about the finishes, and the toxicity of materials is really important. Green roofs. So it's not just the material, but also what's going on around there, the elements that live there. In this case, the biodiversity in the soil and other things. To the side of that, you've got thermally modified timber, so making natural materials last longer by modifying them. So some processes pickle them, some use other techniques to give longer duration. To the right of that, you've got some rammed earth. I'll talk about a project using that a bit later. And similarly, straw bales as well, below that at the bottom left. Then you've got next to that, you've got sheep's wool insulation, fantastic renewable material coming from the son of a sheep farmer. I'm very keen on using that material. To the side of that, you've got sprayed cellulose, which is recycled newspaper. So timber broken down to its most basic purpose and reused is a great insulating material. And on the far right hand corner, you've got carpet tiles made from reused truck tires. So some of these are not natural, but they do show the environmental thought needed around product selection. So if we move on to the next slide, okay, we've got time for a bit of a quiz, a bit of interaction. Which do you think is the best natural material? So you can scan the QR code and we'll give you a minute or so to just have a think about that. Do you want straw, timber, cork, earth, or bamboo? Do you want to all have a vote now? See which material do you think is the best natural material? I like this interaction. You can see the things instantly changing. So some people...
we have a question by Nigel saying, based in what way, which is...
Well, I'm going to come on to that question afterwards, but I think at the moment we're just asking, what do you think is the best overall material in natural material? And then we'll discuss what that means and break it down in a bit more. But your instinct, your first instinct, very quickly, what do you think is best? Shall we end the poll there? So it looks like mud or earth is the outright winner, which I wouldn't have expected, actually. That no one's going for cork or straw, and then bamboo and wood are equally second place. So that's a very interesting result. Well, I'll show you some building with a bit of mud later on, and I'll talk through some of those processes, what things are better and why. But if we move on to the next slide, I think this was raised in the question, and it's always tricky, isn't it? How do you determine what is best? And it does depend on so many things. In this particular question, what material is better? You need to think about the durability, its replacement cycle, as well as the initial carbon impact, which is effectively the embodied carbon is the amount of carbon released in extracting the material, in manufacture and transportation of the material. And so you can get an answer from that, but there's still more things to consider. So if we move on to the next slide, we created this spider diagram when we were trying to explain it to a project some time ago. In the middle, you can see a series of spider diagrams which have 10 criteria. The red is the least sustainable. So on the far outside, all of those things, whether it's embodied carbon, distance, recycled content, rapidly renewable content, packaging, VOCs, durability, reuse, recyclability, and cost, all of those are the worst aspects. And the bottom middle cell shows it the very best, the most sustainable. So there's a very small amount of red in that diagram. But more than that, there's also this instinctive discussion about albedo. So that is an indication of how appropriate that material is to use. So, for example, something may be a very good material, it may be a very sustainable material in certain aspects, but it may not be appropriate to use that material. And so you have to have a reference point of how different materials compare. So on the right hand side, we've got an example to try and explain it a bit more carefully, because this is quite complex. And so we've got two examples of aluminium or zinc roofing, so two metal materials for roofing, and you can see the very different impact on those two things, where the most red impacts are. You can see the grey albedo impact is the same, so that type of roofing impact has the same level of impact. That's where you hope to be under, but you can see where it exceeds that on some of the things like cost or distance for the resource, rapidly renewable content. Neither of these are something which could be classed as natural and renewable within a 5-year timescale, and reuse. Some of them have better, some of them have worse scenarios. So in fact, what you have to try and do is work through all of the systems to try and see which one is the most important. And what most people do is simplify that down to carbon, because this is a complicated thing. So if we move on to the next slide, when we try to think what choice of materials we use for 1 ton of carbon is 1 ton of CO2 is a very accurate way. There are still other factors that affect, and maybe you'll work it out for your particular site that you'll want to get a particular factor will be more important than others. But generally, if you just go on a simple assessment just on material, for 1 ton, you can see that the larger the figures, whether that's clay in this case, compared to the much smaller figures, so the bottom right hand corner you've got stainless steel, you can see how much different amount of material you can use for emitting 1 ton of carbon. So the bigger the area, the more material you can use, therefore it has less impact. And this brilliant exhibition, The Scale of Carbon, which was probably a decade or so ago, was a really fantastic eye-opener for me to walk around this, to see those elements in space, to see the real impact of that, of those carbon impact. But for myself, an archetype, moving on the next page, a lot of what we try to do is use timber. That's our preferred method. I know obviously a lot of people voted as their favourite was mud, but for us, we prefer timber. And I think there's lots of reasons why we do that. And I've tried to articulate some of them here. Firstly, it locks up carbon. Now, I know a lot of people disagree with that fact. The terminology is called sequestration. And some factors account for it and some don't. But effectively, what we're saying is that material, that carbon absorbed during its life, is going to be locked within that timber. And as long as the building isn't burnt down or destroyed, that will be safely stored and not released into the atmosphere for some time. It's a renewable resource. Timber is a fantastic material. Trees do grow, and if they're managed in the right way, can produce a really sustainable source of materials going forward. It's beautiful. The quality of the timber, as you can see, can really uplift spaces. And actually, it's been shown through many studies to be really have many health benefits. The term biophilia, resulting in actually seeing nature, has been shown to reduce stress and have many other health benefits. So it's very, very beautiful. It's easy to construct, as we'll see shortly. And it has a range of uses from structural to cladding, and is very easy to shape by hand, especially if something goes wrong, whereas lots of other materials are not that way inclined. And the material has great qualities in terms of minimizing thermal transfer and weight. So we find that timber is one of the best for us. So we're going to run another quiz now, and just ask, what do you perceive most limits your selection of natural materials? So do you want to have a quick vote? What things? This is a text description. What is your most challenging? And then I'll hopefully try and answer some of those when I go through some case studies in a moment. I'm just going to have a sip of tea whilst everyone votes. There's some really great word clouds coming through. Yeah, lots of these are some of the things I was expecting, and we'll try and talk on. So yes, fire certification, maintenance is a great question, a great challenge for natural materials. How do we maintain them? Lack of availability, and skills, sourcing, humidity issues, availability and structural efficiency, maintenance, and clients' expectations. But yes, the big one is cost. So I'll try and talk about some of those using a few case studies as we go forward. So I'm going to try and switch screens now, and get the same slide. So bear with me just 1 second. Brilliant. Looks like everyone can see that.
Yeah.
Yes, we can.
I just got rid of the toolbar, just in case that appeared. Great. And just going to minimize everyone. Brilliant. So I'm going to talk through a series of 4 case studies: small, medium, large, and retrofit, to explain the benefits and challenges associated with each. And I'll try and pick up on some of those questions that were asked a moment ago. So starting with small, and going back into the history of archetype projects with Walter Siegel's self-build homes. Archetype's earliest work was building self-built houses, and here you can see the benefits of timber construction. Previously unskilled people in the construction trade building their own homes, using a simple pulley system to raise the frame, and sweat equity involved with all the individuals building their own works, meant that they could build their own home for very low capital cost. And as you can see, it's as a group of people, but it's all put up very quickly. And this next slide zooms out on that site. It's not just one individual house. You can actually build a community very quickly. So we've got low cost and speed combined with these actions. And this all centered around the Walter Siegel method of construction, which makes building with timber simple. A straightforward structural grid system allowing ease of build. Archetype took this even further by importing timber I-joists, i.e. joists or beams made from a web of OSB or waste timber compressed into a board with timber battens at top and bottom forming an I shape. And these were first used on our projects in 1992. And the reason we chose this was because it was lighter weight. And so it allowed single persons and diversity of people to be able to construct their own homes independently. If you were if you're trying to fit a large steel beam, you may have seen people try to do that. The weights involved often involve heavy cranes or many people struggling or grappling to try and lift a small beam. So the benefits of timber in this arrangement are, as we've mentioned already, you've got low cost, you've got simple availability, you've got now lightweight. So timber can really benefit some of those purposes and some of those challenges. Now, obviously, what was touched on before was about some of the things about durability. The idea of these simple homes were that they could be built in a way where they could be deconstructed and rebuilt. They could be clad over with a secondary protection or protected with a varnish or staining. They often had big eaves to protect the timber. And the simple structure, as you can see on the left-hand side, just a post and beam onto concrete pads, meant that you could work with varying landscape levels. So I think it challenges and adjusts with most of those things. But yes, there's still, would these types of buildings be available to be built nowadays with fire challenges? That may be more challenging. But certainly when we were building these in the 80s and 90s, it was very accessible and easy way of building. So that's the small scale building. The next scale up is a medium scale project. And here I've selected the Genesis project in Somerset. And it's a real true showcase of sustainable materials. So here we go. It's a whole series of pavilions of different types of materials to demonstrate to students of arts and technology how buildings could be built and should be built. So you can see in this diagram, there's a clay pavilion, a timber pavilion, an earth pavilion, and a straw pavilion, as well as a water pavilion. And each of those different pavilions were made out of their respective materials in different types of ways and in different functions. So if I show you some of the details, here you can see the different design sketches of the 4 key pavilions: straw, earth, clay and timber. Each has their own unique qualities. What I will say is that compared to timber, these materials are much more dense and therefore require much more foundations. And generally, as this has been in the past concrete foundations, and so that impact needs to be considered. I do note that there are advancements and the changes with modern technology, and my colleague Seb Loblomas has just built his own straw bale house, built on a timber frame with screw piles. So there are alternatives now to concrete. But you can certainly see that thickness. There still needs to be thinking around insulation. Does your earth block wall have enough insulation, or does it need insulation on the outside, which is what we did in this situation? Does it have the appropriate fixings and structures? Does it have the right ventilation underneath to make things breathable to deal with the moisture issues as was discussed? So hopefully that gives a little bit of an impression of how you can build different types of buildings, and this is what the sort of the finished building, some of the photos of this finished building look like, and you can see that often these new natural materials don't need additional finishes. So they don't need to be lined in a way with plasterboard or other materials. So that has a unique way of reducing environmental impact and minimizing cost of those building elements. One of the other considerations on this project was water. And so here you can see the sustainable urban drainage system wrapping around the building with the roof rainwater spout on the right-hand side picture pouring into the ponds. Sorry about that. Here we can see a photo zoomed out slightly of the timber pavilion and the canopy going over the top, which joins all of the pavilions together, making it a really nice space. And this final photo of that site, it shows that pavilion sweeping out over the entrance. It shows the clay block building in between and the gabion cage stone walling surrounding the site that made it all level. So hopefully that sort of gives a bit of an impression of what the benefits are. I mean, that particular building was reasonably priced as well. Single story, but medium scale, delivered to a high performance building requirement. The next project is a more recent project, the Enterprise Centre at the University of East Anglia. I was involved in this project from beginning to end, so know this one the best. And it's a large-scale university project. And this project not only uses natural materials, its key focus was to use locally sourced ones. This building, sited in East Anglia in Norwich, really wanted to articulate the natural vernacular. So we've used Norfolk reed on the roof and yeoman reed straw cladding, as many other natural materials, but that really gives its identity throughout. So you can see that the reeds and the straw in the middle. And on the left-hand side, you can see our initial materials map of where we were going to get all of the materials from within that 100-kilometre radius. Here's a bit more of a detail about that thatch facade. And it was a unique design idea. So this was the bespoke vertical thatch cladding, certainly the first in the UK, based on an integrated system on a plywood frame, as you can see detailed on the right-hand side, that neatly fitted together all the way across, so you couldn't see any of the joints. You just got one continuous thatch cladding. You can see it's a ventilated cavity, so it's not providing structure. It's merely a cladding, a rain screen cladding with ventilation behind. But it does help in terms of modifying the temperature of the building internally, reducing the amount of heat gain within the building, making it exceptionally thermally stable, even in very changeable climates. And it's also very simple and easy to install. This managed to get the whole of the building clad in just under 2 weeks, with dropping it onto a split batten process. So, you know, speed of delivery was also one of the great benefits of this material. Another, shown with the photo in the bottom right-hand corner, is that thatchers normally are only able to work during the summer. That is because that's the only time when the weather's good enough to be working on the roof, as shown in the top photo. But with the idea of building prefabricated thatch panels, these were actually manufactured in the sheds. Therefore, we were allowing the thatchers to gain extra work and extra money during the year by doing their jobs in the winter. So there was benefit to the local economy and also saved on time and cost for the material projects. We've carried through lots of the sort of natural materials onto the inside. You can see the timber and the various different pods are clad in different materials. The green is a hemp and nettle mix. We've also got various different types of natural boards throughout the building, and just that lovely space is created, as I talked about before, that sort of biophilia environment from using natural materials and letting in natural daylight. Not only was the straw sourced from opposite the site effectively, just down the road, but the timber we also claimed from local sources, local timber forest. The impact of reducing the transportation carbon was significant. Had it been taken from Canada, it's effectively a 91% reduction in carbon, or compared to Europe, about 70%. In reality, it wasn't quite as easy as that, because the two types of species of timber we chose are only used generally for fence posts. They hadn't got any testing, and so to get them tested and used and constructed and manufactured, we actually had to take them to Ireland and back. So the benefit wasn't as great as is shown there, but that's because our local economy is not set up. So we need to invest more in recognising our local materials, being able to grade them and source them to use them properly. But hopefully, with more examples like this, that can happen. The performance of this building is one of the best in the world. It's assumed to save 68% reduction in carbon, both from operation and from upfront embodied materials over the life of its 100-year notional life. It's also far cheaper to run than any of the other buildings on campus. Yet all the natural materials, all the exceptional performance standards that were delivered, this building was built to below the average of the university cost rates. And that was simply because of the contract used. A sort of collaborative sharing contract, which allowed the benefits to be remain for the client, and so reduce costs, reduce reduce arguments between contractor and design team. And actually, that's the best way to do things. So when we talk about costs, we need to think about the whole system. Is it the natural materials that are wrong or that are expensive, or is it actually the procurement method that we're using to deliver those? So the final project I want to talk on is the very recent project of the Entopia retrofit in Cambridge. This project just won the CIBSE Building Performance of the Year award the other week, because it's transformed a 1930s telephone exchange into a world-leading building. You can see the fantastic energy savings of about 85% from how it was before the retrofit to how it is now. making healthy environment by achieving the Passive House equivalent of retrofit, the Enefit standard, making the space and the environment much more healthy and non-toxic, and also generating energy on the roof. It's how all retrofits of buildings need to be going forward. And a core part of this was using natural materials throughout. The insulation you can see there is a cork lime mix sprayed onto the existing wall, with then a timber fibre bat, insulation bat, installed on top of that to give it even more thermal performance. It's about 80 millimetres of insulation in total to result in 85% reduction in energy. So really big savings through good quality of detailing and installation. But in terms of a retrofit, you're not going to be able to do everything with bio-based materials, with natural materials. Here you can see that we achieved around 35%. And it obviously varies between the different types of elements that we're using. So insulations were high, timber was high, but obviously some of the other elements are very, very low. But we should try and use natural materials wherever we can, because there are so many benefits, as some of them I've outlined already. One of the things we discovered on doing this project, though, was that actually furniture had a fantastically big impact in the overall environmental impact of buildings. And often this is forgotten by designers, architects and clients. Here you can see the graph and the statistics of the impact of just looking at using furniture that's new compared with using bio-based materials and or second-hand furniture. And the significant impact that we've got, about 1/3 of the total impact over that 60-year life through using bio-based and second-hand materials. So it's really important that we think not just about the structure of the architecture, but also about every element within, whether that's furniture or fittings or other things. So hopefully that's roughly come to the right sort of level of time on the talk. So I was going to throw it open for questions and pick up some of those topics that people wanted to discuss more. If any of those case studies or other questions raised, please do speak up and I'll be very happy to talk through them.
Thank you, Christian. It was very interesting. We have already a question from Adit, which asked the question during the presentation. Probably it's a question for the end, and I would suggest him to do it at the end because we can have a chat. So, Adit, do you want to ask the question? Or maybe we can read the question. I will read it for Adit. Do you advocate for natural materials as practice, no matter who the client is, or is this something coming from the client in the first place?
So, yes, I would always advocate for natural materials for all clients, but obviously a lot of clients come to us because of the natural material projects that we have delivered and designed and delivered. But I think touching on some of the points that I mentioned, I think biophilia, health benefits, lower carbon. These are key things which most clients need to be considering and should be adopting. So it won't be appropriate in all instances. As was mentioned about fire regulations, at the moment it's very difficult to get anything above, say, 11 or 18 meters externally that is a natural material because there is a combustibility issues. But there are other solutions to most things, and we should try and maximize natural materials where possible. obviously we need to do it in an environmentally sustainable way. And so one of the questions is, how much material do you need? So often when you're talking about timber, people may go to the idea of using cross-laminated timber or solid timber glued together. But actually, in most instances, if you can get away with timber frames, so timber joists, you use a lot less material. And so if we can use a lot less material with joists and plywood decking, why would you use more timber? You want to keep the natural timbers in the ground and just minimize the loading, minimize the design. So on the University of East Anglia, for example, one of the really radical things we did there was the client brief. We said, you want to use natural sustainable materials, then we're going to have to derogate on loading, floor loadings. The structural engineer says we can do that. It's very safe to do that, but actually we're not going to take the standard requirement. I saw an architects declare presentation once where he said, I think you need 100 people stood on 1 meter squared to breach the loading limit, when actually you can probably only get a maximum of 5 realistically. And that's the difference. If you reduce down your loading limits, you can use a lot less material. You can use natural materials which will span the distance. So the clients need to be challenged on natural materials. Some will be open to it, and some will be harder to work with. But yeah, I would advocate pushing clients to use natural materials in all instances.
Thank you, Alex, for the question. Thank you, Christian, for answering that. The next question is from Alex. Alex, would you like to ask the question yourself?
Sure. So with regards to your school project with the thatch cladding, how long will the thatch actually last in terms of durability, and how will they actually be replaced? Because like it seemed like it was quite hard to install, and there's like concerns with mold or.
Yeah, thank you. That's a really good question. So the thatch cladding has already been up for almost 10 years. It's going to be celebrating 10 years later this year. It's looking a little bit green this winter. That will become a bit less green during the summer, but it's dulled down to a nice grey throughout the whole of the time. How it's designed is, so natural thatch roofs on a sort of 45-degree or 60-degree pitch roof generally last about 60 years overall, as long as you replace the top inch every, say, 10, 15 years, when that bit dulls down to a grey or starting to go a bit brown. That's where the water gets in and just saturates the natural material. But you just replace that small amount, and then every, say, 60 years, you'll need to replace the whole lot. On our vertical thatch cladding, we have the benefit that the rain instantly drips off the wheat straw. It hits the side of it and drops down. So the master thatcher of East Anglia, who we're working with, actually thinks it will probably have a life expectancy of 90 to 100 years. So we're approaching the 10 to 15 years. Well, we're approaching the 10 years, so that 10 to 15 year replacement cycle. So they'll probably take an inch off and refresh that, and it'll look lovely, beautiful, golden again for another few years, and then dull back down. So it's yes, if you work with the way that natural materials have been used, if you look around, I come from Warwickshire, it's beautiful thatch houses all the way along. You know, they do ways of making that, either turning it black or keeping them in their natural blonde colours and dulling to a grey. But they know how to maintain those and look after those. And some of those buildings are centuries old, so there's no reason that it can't be maintained in the correct way. But you do need to understand how you do it, which does require some specialist training in that. It's not difficult. I did some thatch training the other day when I was at the site, but it does need a bit of training to understand how to do it, but it should last for a long, long time.
Thank you, Christian. Thank you, Alex, for your question. The next question is from Nigel. Nigel, would you like to ask that?
Yes, fine, thanks. Yeah, I was at Future Build a couple of weeks ago in Excel in London, and we were talking to a couple of people about natural insulation materials, partly because one of my co-graduates from CAT, Central Alternative Technology, has just set up a company creating natural insulation products up in the Scottish borders. And there seems to be a lot of resistance still from the people I was speaking to, perceptions that you needed it to be too thick. There was a perceived fire risk with natural insulation materials. Do you see that changing?
I think there is still resistance because it hasn't been widely adopted. I think the challenges of post-Grenfell, of regimes wanting much more testing, is obviously going to be more onerous on sort of products that are natural, so they don't have a specific manufacturer body to test them and provide data. You know, when we were doing the University of East Anglia, the information trying to get on straw and thatch was very tricky to get hold of. You know, EPD data, trying to get hold of you know, life cycle information, and all of these sorts of things. So that testing and construction process is harder. Similarly, you know, locally sourced materials, it's harder to get that. You might have the natural England forestry seals grown in Britain, but they may not have the FSC certification, which some people will require for their accountability or for their BREEAM scores or other such things. So using natural materials and local materials is not without challenge. But hopefully the government will, you know, soon introduce some sort of measure on embodied carbon. It's starting to happen in places, a bit in Wales, a bit in Scotland. The GLA on large scale projects do insist upon sort of embodied carbon calculations. And if people adopt the UK net zero carbon building standard, they'll realise that we really do need to drop the amount of material that we use significantly. And the only way we can really drop it is through natural materials. We should be building now to levels that meet the high performance energy performance in use, but it's the natural materials that we really need to tackle, the embodied carbon, the upfront carbon. So switching away from steel and concrete to natural materials is the only way, and especially, you know, petrochemical materials, insulation materials, they have had a lot of financial backing to be able to deliver them cheaply. But I think actually people are realizing that environmentally they're not good for fire purposes. Actually, they're not necessarily better than natural materials. And so, yeah, there should be a recalibration. It was interesting, one of the self-built buildings we built many years ago actually burnt down, and it was filled with cellulose insulation in Lewisham. And Lewisham Fire Brigade, this was the first time they'd come out to a building with cellulose. They didn't know what it was, and they wouldn't want to go near it. But because it was effectively just recycled newspaper, it actually charred like a timber log and then self-extinguished. So there's video cameras of these Lewisham Fire Brigade going to the site, not going near it, it's self-extinguishing, and them saying, we love this material, why is everyone not using it? And this is 20, 30 years ago. But
why still?
Well, exactly, yes. So natural materials do have some inherent qualities which actually make them much better, whether that's slow absorption of thermal heat or whether it's self-extinguishing. And actually, we need to be promoting those more and more. You know, there's some great organizations out there that are doing that, the Alliance for Sustainable Building Products and others. But actually, I think until legislation comes in on embodied carbon or other things that really forces developers or designers to really act and consider carefully the environmental impact, it will still be a tough sell.
Yeah, future home standard is such a disappointment, isn't it?
Yeah.
Yeah.
Nigel, thank you for your question, and Christian
No worries.
as well. Thank you for the answer. The next one is CD. CD, would you like to ask the question?
Hi. Yeah, sure. Um, I'm actually proposing for my thesis project to use rammed earth walls. So I was curious to know what type of insulation should I add in, or would it be okay if I just have that natural rammed earth wall as insulation? So just curious to know what kind of solution would there be.
Yeah, thank you. Unless you're making the rammed earth walls very, very thick, I think you probably will need insulation. So, one of the best examples of that is at CAT, as our previous questioner will be able to attest. There's a great rammed earth building there, but I believe that also has external insulation and then is rendered on the outside. One of the benefits of putting external wall insulation is that you get to see the beautiful inside colours of the rammed earth, and also you protect the rammed earth from the water and the elements. Rammed earth is unfortunately susceptible to moisture and water and needs to be well protected. Unfortunately, the part of the rammed earth wall at the Eden project got attacked by water because the overhang was big but not quite big enough, and so that actually that was damaged and had to be redone or protected in some other way. So you should probably put some insulation on the outside. I don't know what the latest U values are that you'd want to, how thick you'd want to do it if you were not putting any in, but I would imagine it would probably be a very thick rammed earth wall if you had no insulation at all. Then what insulation you put on the outside, I think you'd want a natural breathable insulation material. I would avoid using petrochemical based situations because they will stop the breathability of the natural moisture that will go. The moisture will be absorbed from the room into the earth wall, and you want to get that going out to the other side. So you could use cellulose if you had if you had some sort of formwork around it, but more likely you'll probably use something like natural wood fiber bat or similar with a lime render on the outside to allow breathability all the way through. But yes, it would probably be worth investigating the CAT project if you have a look at the Genesis project as well. The details we showed there at a scale, you can have a look at that and see. But that was 2004, so that was quite a while back. So insulation requirements will have increased, no doubt, since that time.
If I can just jump in, Cat do short courses on rammed earth, I think, weekend stuff, or maybe a week.
Good.
I'll put the link in the chat.
Oh yes, you can put the link so everyone could access that link. And thank you, Sidi, for your question. The next question is from
Yes.
Mylind Kurgold. Is there a Mylind? You wanna ask the question? Okay, I'll read the question then. Is there a lookbook of some sort of technical details for using natural materials?
There's lots of books. I did consider putting a slide with all the books that I've talked about and read. There's some great books, so I'm going to list some recent examples. So Hattie Hartman and Joe Jack produced a book called Materials last year. Fantastic book that goes through a whole series of natural materials, telling you the benefits and otherwise of those, whether that's straw, timber. Oh, sorry, lights are dimming. I just had to activate those. straw timber, all the way through to things like mycelium and other such things. So yeah, do have a look at that one. There are some much, there's a good stock of older materials, specific books on particular projects, so you can easily find books associated with straw bale construction, for example, for hemp construction, for various different individual books, timber as well. There's lots of really great books on timber buildings, but most of them are. Most of the ones I've read are probably quite old. So I'd have a look at, as I say, the materials book by Hattie Hartman and Joe Jack is a very good primer for understanding, and has a really good overview of EPDs and other things at the front.
Thank you. Thank you for the question, Maiden. Yes,
Sorry,
please.
if I can interrupt with elaborating, like adding to that question. I think I've gone through Hattie Hartman's book with materials, and I think it gives a good overview, but I probably think if I wanted to, let's say, design something with natural materials, I probably need more knowledge than knowing that it's a good material. Like, what kind of details do I put in? What kind of joinery details, or how do I say how this build up works for it? So is there some sort of, I mean, I don't know if that was a question, but like,
Yeah, I was okay. So the other one is the trying to wrap my name for the exact book cover. I can probably can I do a do you want to share screen, and then I'll look for it online. I've got a great source book of natural materials that I got from the Architectural Association last year. I can see the cover. It's green. It's got a lovely house, but I can't think what it's actually called or who it's by. So I'm going to just try
you
to.
can stop sharing because we're anyway doing Q&A. So.
Okay, I'll stop sharing, and then I will. How do I stop? There we go. Stop sharing. Brilliant. Give me 1 second. Oh, it's not coming up. I'll send a message afterwards rather than
No
keep
problem.
everyone
Okay, thank you.
far away with any other questions, and I'll send that afterwards.
Okay, thank you. The next question is again from Alex. Alex, you want to ask that?
Yes. Where is it? Yes. So earlier you had mentioned about the recycling or reusing materials. But like, how would you actually implement that within terms of like structural stability? For example, like using reused brick or reused concrete, maybe you can't really test it because like destructive testing will destroy the material. So how do you make sure it won't collapse?
Yeah, so I mean, this is again similar to the natural materials debate. How do you know whether the materials fit for purpose? And that is a challenge. So on the Entopia project, the retrofit I showed last, that used reused steel for the PV canopy on the roof, which was actually from the Marvel film set. It was a lighting rig for the lights, and the suitability came from the manufacturer. The manufacturer had to do their tests and assess and confirm that the suitability of that metal was suitable for what you want to do. And for each different material, that will be a different testing and a different system. And that's where reuse of materials is really challenging. But there are people now out there doing that, and there's a lot more emphasis on getting reused materials, getting recyclable materials. And so there's lots of organisations trying to take what they can and reuse it. Sometimes that will be repurposing it. So University College London have done some great work in creating cross-laminated timber made from reused timber, effectively pushing it all together and gluing it together to make it actually have a stronger impact than whatever the material was before. And that's, in the same way that plywood uses timber and actually makes it much more stronger by gluing it and then using timber in the other direction, the product can be improved. So in terms of brickwork, whether that can be reused, I mean, taking apart brickwork is challenging. Often, if it's not done with lime mortar, they will stick together and there's a problem. But what they've done in some places is cut out whole sections and fit them together. But mostly, as you say, most natural materials or reused materials will not be used for structural purposes, just because structural engineers won't know the full pedigree, and unless you're doing destructive testing, it's too much of a risk. But I think I think there will be more developments on that. There will be ways that we can resolve that, and we can reuse more materials. But yeah, it's too much materials go to waste at the minute. And we really need to impact that and change that. Lots of materials do not need structural strength, and so we need to use them appropriately. So can we reuse things on areas where we don't need structural strength or fire resistance, for example, or whatever other technical challenge it is that we're struggling to overcome? Can we use the majority of things? I mean, in terms of bricks, I attended a CPD the other day that said effectively 88% of all the bricks we import in the UK could be met by reusing bricks in the UK. That's a staggering amount of bricks that are being manufactured either in the UK or abroad and shipped across, that we could reduce our emissions by reusing materials. But it's easier and cheaper at the moment to discard them and throw them away. So we really need to try and adjust the mechanisms to retain buildings and to make retrofit and reuse cheaper than new builds. And whether that means taxing new materials and giving tax relief to natural materials and circular materials, I don't know, but something needs to change to make it more viable if we're to hit the sort of climate targets that we're as a nation signed up to.
Thank you. Good question, Alex. The next question is from Nigel, who cannot read the question, so he asked us to read. At Archetype, what is your first point of call on project, considering the design from a bioregional perspective?
So is that sort of the material mapping? Is that question asking? I guess we'd try and, yeah, for bioregional, we'd try and find out what materials are in the local area. And that's simply just a case of often Google searching, just trying to locate manufacturers, trying to locate what sources are available. We had a very good CPD a long time ago from people who do this in difficult circumstances, where they're building for people in need, in countries where there aren't much resources. And actually, you just have to locate what's in the local area. What can you utilize, and how can you best use that? So we covered some of those same mapping exercise, and we tried to find out what's in the local area, what is natural, what's used. So at the University of East Anglia, we found local flint from local beaches. We obviously knew about the Norfolk Reed in the Norfolk Broads. There was hemp. There was all sorts of various different materials throughout the local area, which were really great. We considered some which we disregarded. So we knew that there was a large Burned Matthews turkey farm. So could we reuse turkey feathers as insulation? You know, there was all sorts of wild ideas. Some of them you'll reject, and some of them you'll say, yeah, that could be a really good material to use. But sometimes it's from that, as we say, 100-kilometer radius, 100-mile radius, or sometimes it will be, what have you got on the site? What is there? Are there trees there that are available that you could utilize some of those things? Is there space on your site that you could grow the materials that you need to build your building? Could you grow willow? Could you grow crops to that you could harvest to make your building before you start? Or, you know, what else is there? Could you dig in the ground and find stone? Could you are you on the side of a hill and actually you could excavate some of that and reuse the earth? You know, there's all sorts of thinking. So start with the immediate site and then move outwards in concentric circles to see what availability. Obviously, some of the more important things like windows and other things like that, glass, will need to come from specialist manufacturers, which are probably further away. But you never know, there might be a manufacturer of some of the materials that you require just down the road, and it's trying to work with them to make them fit on the project, to reduce transportation carbon, but also obviously working with costs and various other things. But yeah, it can be successfully done.
Thank you, Nigel, for the Neil for the question. And it's good now in the chat we have Nigel, who left now because I need commitment, who post the link for the Center for Alternative Technologies, building with that and natural fiber events. So if you're interested, there's the link. Please looking at that. Thank you, everyone who is leaving on this number. We have Alex, another question. Alex, please.
Well, Catherine, do you want to ask your question first?
I can do. Can you hear me? I don't usually get involved live in these things.
It's very low. The volume of your voice is very low.
Okay, is it any better now?
Oh,
no, wait. No, is it any better now?
oh,
Perfect.
fantastic.
Sorry, I'm so sorry. Anyway, yeah, can you see the question, Christian? It's about retrofitting windows in your home, and they're always smaller because of the heat loss. What can I do? Do I just accept it? And you know, the glass area is going to be smaller, so the room might end up slightly darker. And because I'm thinking, if you're building brand new buildings, you can maybe make the aperture bigger to begin with, so that you don't lose light into the building. So, but in a house that already exists, I don't really know what to do.
So, I mean, it depends how you're retrofitting it, doesn't it? So I'm looking at retrofitting my own house, and I'm looking at putting the windows on the outside of the building. So I'm going to be putting natural insulation on the brick walls, standard solid brick wall. I'm going to be putting timber insulation on the outside, hopefully 200 mil, might be slightly less than that, but around 200 mil of insulation on the outside. And I'm going to push my windows on the outside of that, so I can maximize the size of those windows by building the frame on the outside of the frame and make the glass almost the size of the whole aperture. So you can do that, but I guess each design needs to consider their own impact. Having excessive glazing is not necessarily always a good idea. It can lead to overheating. If you have a thermally massive building, adding lots of heat into that building, it won't change temperature, it will continue to rise, and it could lead to overheating and serious issues. So new buildings have to comply with overheating regulations Part O, but retrofit buildings, unfortunately, at the moment, I don't believe do have to do an analysis. So you want to be careful of those sorts of considerations. So Yes,
Thank
using
you.
timber framed windows will be thicker than using metal windows or plastic windows. But I think actually plastic windows, they say last forever, but there's a whole scrapyard full of plastic windows at the moment. And one of my colleagues, Robin, always used to say, if they're so good, why do they provide them with these maintenance paints and things like that if they're all natural and don't need anything? But timber windows, if you maintain them and protect them, can last a lot longer and actually have a much better thermal performance. And often some of the new high performance windows, such as passive house windows, have natural insulations inside them. So you'll have a timber frame window backed with cork insulation to really give it that high performance thoughts. So hopefully that sort of answers your question and adds a few more bits to think about.
Thank you very much.
Thank you, Catherine. Now we have a couple of questions from Alex. Alex, please.
Oh, sorry. So earlier when you were mentioning about the bioregional and you were mentioning about how you found all of these like different resources and things, how exactly did you go about this search? Like I heard you had mentioned the Google, like just Googling it, but like how were you able to know about the willow, about the turkey farms, about like all these different resources? Did you like hire someone or how was the survey done?
So so it depends exactly where you are. If you're doing it for your own building and you live there, you can just go out on the streets and have a look. Otherwise, we were using electronic systems. We were just looking what sort of materials are there. So we were just searching for forests. We were searching for recycling centres. We were searching for manufacturing things. Google Maps will show you all the various different establishments, and you can quickly ascertain which manufacturers and others are in that locality. But if you are there, it's better to just walk around and have a chat in that local area and see what materials are there. But in the sort of the larger countryside, if you're talking about sourcing natural materials, that can be harder. But it's pretty clear where forests are. Getting the materials from the forestry is harder. So we were able to ascertain who owned the forests and try to work with the BRE and with our structural engineer to get access to that. It was forestry land to pick ones and be able to harvest them ourselves. So it's trying to build relationships with those stewards of the land, whether that's farmers, whether that's landowners, whether that's forestry managers, to see what natural materials are available. Some of the things, may not be available at the time of year when you go. So particularly if you're talking about natural crops, they may grow certain crops for just part of the year, and they may use it for animals at the other times of the year. So it's worth thinking holistically and engaging with those local farmers, see what they will grow and what they do grow. So it may be you can access hemp, or it may be that you can access straw or wheat. But yes, it will depend. And it's all about availability. They may not have the material available when you want it. So that's the other challenge to consider. How do you ensure that you get what you want when you want? So when we talked about the thatch cladding, that was really important that we harvested it at the right time, bought that, and then the thatchers thatched it into the work over the winter, so that we didn't have to wait for another harvest season, which would have delayed our project. On large scale projects, that can be tricky. So it's not always possible to get some of the things you want. I had someone speaking with me trying to use straw bales not too long ago, and I had to inform them that actually last year with the wet weather, there wasn't much crops grown, and so actually straw was going to be much more expensive than they had initially factored. And so it's working with local agricultural suppliers to sort of ascertain whether the costs are the right for your building, and you may need to adapt materiality. And that's one of the great things of using natural materials is they have that variability in their finish. There's always a textural quality that changes from product to product, but also they have that variability because you may not be able to use the same batch. You may have to use something slightly different. You might have to mix and match and have various different things. You might get timber supply from one set of trees, and then they may not be able to get it. You might have to get one from somewhere else, and there will be a variance. There will be a difference between those types of things.
Christian, we have another question from Alex. Alex, please.
Sorry. Is there enough time for more questions? Or
Yes.
okay. Yeah, so on the topic of like rammed earth, which was earlier, how do you balance between like the insulation and like the thermal storing? Like I had learned about like how rammed earth is like great at like storing like the energy, like or the heat, and then releasing it during the night. But if you have the external insulation, how can the heat actually be absorbed or pass through?
Yeah, so we will reduce the amount of solar gain onto that. So you will limit the amount of solar input going through the building. It will still happen. So there's a book that I got from Cat actually, which explains about the wavelength of how different materials will impact whether you have the insulation on the inside or the outside. Our old office, the office we used to be in 10-15 years ago, we were in a solid brick wall building, and we always had to take a tea break at 4 p.m. because we knew that the heat from midday would come through the brickwork 4 hours later and hit us at precisely 4 o'clock. So we just had to have a tea break because it would just be too unbearably hot. So that had no insulation. That was just the heat transfer through brickwork wall. If you put insulation on the inside or you put insulation on the outside, that varies. But I mean, there's quite a lot of variables in there. So you'd probably have to do a proper thermal calculation to work out how much thickness and what impact that has. It may be that you're actually that heat comes through, and if it's 12 hours displaced, it may be beneficial. It depends on the type of building that you're using. You may want your heat not come through the building, but to heat it at night effectively. So you have that sort of constant temperature without heating and cooling. That's the ideal solution for lots of buildings. But working out how much insulation and what the properties of those insulations are, the thickness of it compared to the rammed earth, would require sort of a detailed calculation to be able to say whether it's beneficial or negative, and you may want to adjust one or the other to make it work for the occupied function of the building. Sorry, that probably doesn't help that much.
No,
but
yeah. Yeah, and then I had one more question. Sorry. There was one time I heard someone mention that when looking at sustainable buildings, there seemed to be like a narrowing of like what sustainable quote unquote looks like, with like more blocky forms and like asymmetrical roofs and things like that. And there's oftentimes seems to be the stigma of like sustainability being seen as like boring. How would you contrast this, or how would you like combat this, especially when considering that passive house generally tends to lean to more compact buildings that sometimes don't seem as aesthetically pleasing?
Yeah, we get that a lot, that people think passive house in particular is blocky or simplified. I mean, I guess the first passive house project I worked on, which would have been the first non-domestic passive house in the UK, had unfortunately the funding stopped on the project, and so it wasn't actually built. We took it out to the contractors, and then it was for a sort of children's centre, but those sort of fundings were stopped, and so the building didn't progress. But effectively, that was a round cone, if you like. The optimum performance of a building is circular. You know, you get the best surface area volume. It would be a globe, effectively a sphere. So it's easier to build a square. That's why people build square, because it's simple and easy to build, not because it's the most efficient. And so, you know, you can build passive house buildings, you can build buildings out of natural materials in any way you want. It just takes a bit of thinking and a bit of thought and careful work. The cat building we mentioned, the rammed earth cat building, is circular drum. It may have another bit of a circle going off of it as well, semicircle. Beautiful building there by Pat Bora. There is great examples of natural materials being used to build wavy structure. All, you know, throughout there's lots of precedents of historical natural materials being wavy and bendy. Have a look at some of Grand Design's really outrageous sort of buildings with natural materials which have got wavy structures. You've got fabulous things like grid domes. You've got fantastic three-dimensional shapes that flex and form and are beautiful to look at. So yeah, I don't think natural materials need to be square. I don't think passive house needs to be square. But if you want to save money, if you want to build it cost effectively, cheaply and quickly and easily, you'll end up with a square solution.
Thank you for the question. Thank you for the answer as well. It is not a question. It's a nice message from CD. Thanks, Christian, for this amazing presentation. Especially, I was impressed at how effective your team can apply the collaborative techniques and create truly sustainable community. That's nice. Thank you, CD. Any other question?
So there's one from Alex Hart in there, please.
Where is that? I missed that.
Hello?
Alex, are you here?
Yeah, can you hear me?
Yes, please, ask the question.
Yeah, hi, thanks. My question is on hemp. Let me just read the question out. So, hemp has many uses such as hempcrete, insulation, wall panels, roof tiling, hemp wood, hemp fabrics, hemp paints and coatings, hemp composites, hemp resins and adhesives. I've been reading that hemp is good for health and good for the environment. So I was just wondering, why aren't more firms using hemp, or are they? And what is your view on hemp as a multi-purpose natural material? And then I had Nigel respond that there's a student who started sourcing hemp because there was no UK sources for hemp. So, and he had to import this from Europe. So why is there not, is hemp not wanted in UK, or what's your view on hemp basically as a material for architecture?
Yeah. I don't have any strong feelings against using it. I haven't personally used it other than insulation bats. I haven't used hempcrete projects, but I have seen some, and I hope to go and see one around the corner from my house. Actually, somebody was building one the other day I saw, and I thought, oh, I've got it. I must get back in touch with them and go and see that. But yes, so there are definitely some really great buildings being built with it. I think the challenge, as you say, is where does it come from? So, I looked at using hemp flooring, hemp floorboards, and may use that in certain areas of my home retrofit. And then I asked them, where does it come from? And it's all imported from America. So it's that carbon offset of the do you use it? I think it looked a great product. It looked really nice. But I think the challenge in the UK market is probably from the hesitation around cannabis and other things like that, that
So
actually
it's regulations,
I think it's regulations. I think you
Okay.
have to be licensed in order to grow hemp effectively because it's part of the marijuana sort of
Yeah.
thing, even though obviously we used to have lots of hemp for making ropes for shipbuilding and all these
Yeah,
other things.
exactly.
But I
Yeah.
think at the moment there's very few and far between manufacturers of it in the UK, and therefore there's a cost and environmental impact of importing it.
Yeah.
The hempcrete, where it's combined with concrete, I'm not sure about as well, but it probably is better than concrete on its own. So
Yeah.
it reduces the amount of concrete, so that there's benefits with that. One of the challenges with using natural materials is areas that are below ground. Because of
Right.
water
Okay.
issues,
Yeah.
and I think hempcrete could potentially be used below ground if done in the right way. So
Okay.
that opens it up to lots more possibilities of maximizing natural materials, whereas other ones you just can't put timber below ground in a basement or something like that. It's just it's not a sensible idea. Straw,
Yeah.
similarly, all these other ones. So on that principle, hemp may be a very beneficial one going forward. And yes, we need to move on encouraging more manufacture of that. But again, it's always this, it's what's the cost. If the market's not there, people are not going to grow it because
Yeah.
it's just not worth it. And then there's the cost associated with the costs will go up if you do that. So yeah, it's a challenging one, but hopefully more and more of that can be used. Yeah.
Nice. Nice. Thanks for your answer. Thanks a lot.
Thank you.
Thank you, Alex. And sorry, I was missing your question because it was in a reply.
It's okay. It's all
Sorry
good.
about that.
It's okay.
So if we don't have other questions, I would say it was a great, not just the talk, but the chat as well, because I think chatting is an opportunity to go more in depth on specific, let's say, areas and make sure that we know more, we get to know more about the topic. And as in the previous lecture as well, it's about assessing, it's about the wider assessment. It's not just the first choice or what it seems like the right choice at first glance. It's a long assessment, and probably we need always to select the right material that fit that context, fit that project, and of course, as we learn now, we need to use more natural materials. On that note, I will leave the stage to Dipsy.
Yeah. I'm just gonna present my screen again. If you all can see that.
Yes, you can.
Okay. So yeah, if you can all pick up your phones again and scan the code for the last question before we head off. Please let us know what were your key takeaways from this session with Christian and what you learned from it and how you think you benefited from this. Some really nice answers. Natural is better when it's used the right way. Great. That's some really good feedback, and it looks like everyone's learned quite a lot from this session. Thank you, Christian. Thank you so much for being a part of this session, and I hope to see you all in the next session as well. 2 weeks from now with Thomas, who's going to be elaborating about operational net zero in new build buildings. So thank you all for engaging so far, and I hope you have a good night and see you soon. Thank you. Thank you, Christian. See you.
Thank you. Bye.